Thank you, Sarah. Let me just reiterate what Sarah said about formulation chemistry while John is miking up. If there's any expertise in the room, please come and see us. We imagine the challenge of applying novel chemistries to concrete and mud surfaces, which for the foreseeable future is pretty much what we have in Africa. We have the chemistries that can provide the long persistence needed and maybe can completely revolutionize the way IRS is done. But you have to be able to make those products bioavailable on what is actually very, very aggressive surfaces. So it's a whole area that we are really investigating, and any technology there, we'd be happy to talk to people. Let me introduce John Lucas. John Lucas has over 30 years of experience in the development and marketing of public health and consumer insecticide products, having worked for Wellcome Research Laboratories and legacy companies, including Roussel Clough, Agrivo, and Aventis. John is currently Business Development Manager at Sumitomo Chemical Company and is involved in the development and marketing of a wide range of highly successful vector control products such as Olicet, Net, SumiPro, SumiLarv, and more recently, novel resistance management tools that include Olicet Plus, Olicet Duo, and SumiShield 50WG. So John, over to you.
Am I wound up? Can everyone hear me? I'm wound up?
Yeah.
Okay, thank you. Right, thank you very much. I have the dubious distinction of probably having the longest presentation title at ASTMH, so I've actually shortened this to be a little bit more palatable for this time in the morning. But today well, I didn't think you could. Could you wind me up? Thanks for telling me that. Most people normally can hear too much.
Putting it the right way up, John, helps. Give it a go.
Right, let's try again. So as I was saying, my previous title was pretty long, but I've cut this down to make it palatable for this time in the morning. But I want to talk a bit about clothianidin, which we see as a very exciting new vector control tool. Of course, Sarah's already talked about the resistance threat, but there is evidence around the world in the field that there is resistance in multiple locations to pyrethroids and other insecticides, to all the classes, in fact, and all the major transmitters of malaria. One of the big concerns is the signs, I think, are already there. We've seen presentations at ASTMH and other parts of the world, other conferences where they've shown experimental hut data with very, very poor levels of mortality and all the other entomological indicators showing nets are really starting to fail. And also, even in areas of extensive coverage of bed nets, there seems to be still high levels of transmission going on, which is very worrying. So we think this could be really the tip of the iceberg. I'm very concerned that this might be a tipping point and lead to higher levels of transmission again. So if we look at the IR mapper, we can see here, and I'm sure you're familiar with the IR mapper, but you can see that in 2000, we've got significant levels of resistance in Africa. In Southeast Asia, apparently no apparent resistance at this stage, but if you look at 2005, you wind the clock forward, there's significant levels of resistance appearing. The red dots are signs of resistance to insecticides. 2010, that spreads, and by 2017, the picture is pretty nasty. Another way of looking at this is to look at the numbers of areas where classes of insecticide are resisted, and this is WHO data from 2015. There's quite a few areas where one class is resisted, areas where two, areas where three, and very worrying areas where four classes of insecticide, all four classes of insecticide are being resisted, particularly in Ghana, Tanzania, and other parts of the world. So, Sarah's already mentioned the GPerm. There's this very lovely 132-page document. For those of you who like a digested version, there's a 24-page executive summary. But if you go into the GPerm strategy and have a look at this in some detail, there's a short-term, a medium-term, and a long-term strategy. And it's the short-term that's really calling out to manufacturers, asking us to develop tools to try and manage resistance. And there's several different pillars, and the third pillar of the strategy again calls to manufacturers to develop new, innovative vector control tools. If you look down into this pillar 3, it talks about sustained investment required to develop new tools and active ingredients, and that's really a call to action for industry, and we and other players have listened to that call. If you look, again, one of the other comments in this pillar was that 2 new products, a reformulation of an existing AI, an OP, that's Actelic 300CS, but also chlorphenapir being repurposed as Silando 240 SC, were expected to become available for IRS in the near future. This is written in 2012. So 2013, we have the HUPACE 2013 report stating that pyrimidine methyl has actually obtained HUPACE recommendations. So that's really good news for the IRS community. But sadly, chlorphenapir, the report confirmed that further evidence was required to assess impact. 5 years further on, we're really hoping for some breakthroughs here, and chlorphenapir is again reviewed by WHO and HUPACE, and confirmed that it showed promise, but again, further evidence was required to assess impact, noting that this chemistry is not a neuroactive insecticide, it's a pyrrole chemistry, and it works by uncoupling the oxidative phosphorylation. And so as a result, it was determined by WHO to be a new class of insecticides for IRS, as it didn't fulfill the current WHO cutoff criteria. And that's a real shame, because this could have been one of those tools that Sarah was talking about. We need new tools for IRS. Let's just wind the clock back for a moment to 1945. And no pun intended, but in 1945, what tools were in the product pipeline? Notice the chap's rather fine pipe there. Of course, we all know that in 1945, it was DDT. That was the product in the pipeline. That's what was used. And this is spraying in Naples being conducted. So let's wind the clock forward to 75. That's 30 more years. So what have we got in 30 years in the toolbox? Well, pleasingly, we've actually got 3 new classes of chemistry introduced, so roughly 1 every 10 years. So that's pretty good going. So we have OPs, carbamates, and pyrethroids. So let's go forward. 2015. What have we got in 2015? That's 40 more years. Now, I know you know this, but it's sort of amazing that 40 more years have gone by and we've still got the same 4 classes of chemistry. So perhaps it's not a surprise that we've got high levels of resistance occurring to these chemistries. So we really need to address the need and look for new chemistry. And clothianidin is a neonicotinoid. It's an IRAC group 4A mode of action, so it's a totally new class of chemistry for vector control. And it's been repurposed from ag, and Sumitomo targeted this for use as an indoor residual spray and formulated this as Sumishield 50WG, containing 50% clothianidin. It's a really nice product, actually. It's dust-free, goes into a tank nicely, and here I'm going to need some help to just activate this video. Can you just click this forward? Thank you very much. This is a water dispersible granule composed of small, cylindrical, free-flowing granules. It's not dusty like a wettable powder and forms a very nice, easy to transport material. If you can activate the next picture. So when you add this to water, very quickly you can see it dissolves, disperses very nicely, dilutes very readily in water. Even just reaching the bottom of that column of water, it's nearly fully diluted. And then if you just invert, as you would do a spray tank once or twice, you get a nice stable suspension which meets all the criteria for WHO's indoor residual spray products. So we did some in-house studies at the African Technical Research Centre in Kasongo. And we looked, the first thing to do was looking at what was the dose rate, and we looked at extensive internal studies on a variety of surfaces, mud, brick, wood, painted surfaces, to determine that 300 mg per square metre was the best dose to give good and long-lasting biological activity. So we then moved to HUPACE, and in 2014 we initiated phase 1 lab studies at IRD Montpellier. And then we did some phase 2 and phase 3 studies that followed in Côte d'Ivoire, Tanzania, and India. And some of the cooperators we worked with, I believe, are in the audience today. And then we conducted trials, independent, other trials in other parts of the world as well. But I'll just focus on the trials that we put up here. Just to digress for a minute, this document was put out in 2017 in May, which outlines WHO's revised evaluation process for vector control products. So this has come after all this data has been generated. So this is an important document for us to look at, because this is sort of a new set of goalposts to a new set of criteria that we have to meet. And this document basically clarifies which malaria control interventions currently have a WHO policy recommendation. And it quotes, and this is very important, directly quoted from this, entomological indicators will need to confirm that the product under assessment is non-inferior to a suitable comparator. So just bear that in mind when I share some of this data that's been generated before this document came out. So just thinking about the phase 1 studies that were done in RRD Montpellier, this is all lab-based. Surfaces were treated with a compression sprayer, and that was checked and shown to be within the target dose by weighing the surfaces. And it was confirmed in these studies, they looked at a range of doses, that 300 mg clothianidin gave the residual efficacy that we had seen, greater than 12 months on wood, cement, and mud. So that's a good finding, and that allows us then to move forward into our phase 2 and 3 studies. They also noted that clothianidin, because it acts on neonicotinoid receptors, there was no cross-resistance observed on pyrethroid-resistant KDR and resistant mosquitoes, or OP-resistant acetylcholinesterase and carbamate-resistant strains by topical application. We then moved to phase 2 and 3 testing. And all these studies were done with a compression sprayer fitted with a control flow valve, which gives you a nice, even distribution. And another nice little thing we did, we weighed our sprayers before and after each treatment to confirm that we were within target, which is a lot quicker than doing filter paper analysis. That filter papers were done too, but this gives you a really quick check to confirm that you're within target, and pleasingly we were. And the target application rate of 30 mils per square meter. And due to the additional kill we see over time, we took observations daily for 7 days. Now, I've shared some of this data before. I've shared this last year at ASTMH. But I'll share it again, particularly in view of the need to show non-inferiority, the new guidelines. So these are phase 2 studies conducted with very, very resistant mosquitoes in Tiassale and Côte d'Ivoire. This work was done with the support of AVECNet and IVCC, so thank you very much, Nick, and for AVECNet and the audience for support. These were cement-walled huts, SumiShield applied at that 300 mg dose, Actelic at the 1 gram dose, and then 30-minute cone tests on lab and multi-resistant wild strain Anopheles gambiae. These are these very resistant Tiassale mosquitoes. And we did observations for 24 hours, but then continued taking observations to 168 hours. Just to quickly then look at these results. On the left, you've got Kasumu, right wild, mortality on the vertical axis, and then residuality up to 9 months. So the first set of data, 24-hour mortality, that dotted line is the WHO 80% cutoff. You can see there on the left-hand side, Kasumu achieving that cutoff up to about 6 months. If you then look at 48 hours, for both Actelic and SumiShield, notice the lines are pretty parallel. And also notice control mortality is pretty low. I'll just click this forward. That's 48 hours, 72 hours, 96, 120, 144, and 168. Still no control mortalities. And at 168, you're seeing at least 6-7 months of residuality, right on that borderline, possibly 9 months for both Actelic and SumiShield. So very little difference between those two AIs, which is very interesting. Just looking at the phase 3 studies now conducted in Côte d'Ivoire. This again was with highly resistant Anopheles gambiae with 3 study arms, with a water, an Actelic and a SumiShield arm. And this data will be presented in much more detail at the MIM conference, but I just wanted to give you a little flavor of the cone test data. Initially here, this is looking at susceptible mosquitoes, same layout with a residuality along the bottom, mortality at the top, and that dotted line's the WHO 80% criteria. And you can see Actelic and SumiShield a bit noisy at 24 hours. 48 hours, it sort of sorts itself out. Both products looking pretty similar, 72, 96, 120, 144, and at 168, I think they are, significantly very similar. Actelic possibly slightly less residual at the 6-month period, but this is susceptible mosquitoes. So we then said, okay, let's just look and see what effect we get if we introduce resistant field strain mosquitoes into these huts at 7, 8, and 8.5 months. So here's the same data again, same sort of plot, at the 24 hours, and at 48 hours you can see both Actelic and SumiShield pretty similar, and then moving up, 72, 96, 120, 144, 168. And 168 hours, pleasingly, we're seeing that both products are giving very similar residual performance and still performing very well in these huts, even at 8.5 months. So that's really, really encouraging data. Just one more bit of data to look at, and this is the Tanzanian phase 3 British scale trial. I'm not sure if Sarah Moore is in the audience, but Sarah was responsible for leading this activity. And the primary vector there was Funestus, with a secondary vector Arabiensis, resistant to all classes of pyrethroids and susceptible to p-methyl. And again, 2 treatment arms, Actelic at the 1 gram rate and SumiShield at the 300 mg rate. Again, this will be reported at MIM. I just wanted to give you a little flavour of just a few of her findings. Her summary of her findings, she found that SumiShield was equal or superior to Actelic CS for each of the outcomes measured. And the residual efficacy for SumiShield was about 8 months and Actelic about 5 on these brick-baked houses. Mortality of wild mosquitoes was greater in the SumiShield arm than the Actelic arm for both vector species. And nicely, there was the feedback from the local residents was both treatment arms were very well accepted. Sarah took all that data and she took a sort of average data from the cone mortality between the January and the August time periods, and she averaged it at each time interval, so 24, 48, and so on to 162 hours. And you can see here the average mortality for SumiShield is significantly better than that for Actelic. So the conclusion of that is that SumiShield is not non-inferior, if you can have a double negative. It's superior to the Actelic in this set of studies, which is, again, very pleasing. So now come back to WHO. WHO convened an evidence review group, an ERG group, very, very recently, just back in September. And the SumiShield's data was included in the review to see if IRS policy recommendations could be extended to include clothianidin. And very pleasingly, their key findings were that SumiShield meets the current WHO efficacy criteria for IRS. It has similar entomological effect to other IRS products that are currently covered by WHO policy recommendation. And that was, they were looking at Actelic particularly here. So the existing recommendations for RS could be extended to include SumiShield 50WG. So now we have another tool for this toolbox, which is great news. And also recommending that national control programs and their partners should consider deployment of SumiShield. So we like to think this is a bit of a double first for us. The first WHO pre-qualification for a vector control product, just in October. This has just happened. This is really hot off the press. Remembering that the WHO's pre-qualification system has recently replaced, the WHO pre-qualification system has recently replaced the WHO's system for product recommendation. And the other first is it's the first WHO recommended new mode of action chemistry for IRS in 40 years. That's some achievement. It's actually, I have to say, it's really embarrassing to stand here and say that. 40 years is too long. It's a disgrace, really, to our industry. We should have had it 20 years, 10 years ago. It's far too long to wait. So for those of you who are interested, you can go on the WHO website and you can see that SumiShield is listed. And those of you with good eyesight, you can look and see that it's actually listed with a reference 001 for the first product to be listed and 001 for the first company. So Sumitomo's 001, which is quite pleasing, really. My boss is down here, so I get a bonus, I hope. So anyway, just in summary, a new mode of action insecticide, this is SumiShield, for vector control, meeting an urgent and very, very, very desperate need. And we have a claim for up to 8 months duration of activity under field conditions for use in resistance management programs as one of these tools for the toolbox. It's a WDG formulation, which is really nice to work with. It dilutes readily, it's odorless, it's dust-free. Easy to use sachets, it's easy to transport, low mammalian toxicity, and of course pre-qualified by WHO. So if we now just go back to our chap here and see what's happened. In 2017, we not only have DDT, OPs, carbamates, and pyrethroids, but we also have neonicotinoids, which is really, really good news. But I really hope that chlorfenapyr will follow. We really do. I'm not just saying this. I'm genuine about this. So giving programs even more choice and more opportunity to implement rotation and so reduce the chances of resistance developing. I'd just like to put a final word up. Sarah, are you in the audience? Yeah, there's Sarah. Thank you, Sarah. Sarah wrote me an email having helped review some of this data and generate it. And I just asked if I could quote her. And she says, it feels really good to be able to be part of something that will save lives in the future. It's a good reason to get up in the morning. And I think all the team in Sumitomo would echo that feeling. And hopefully those of you around the room also share that feeling, and hopefully we'll not only be able to contribute to saving lives, but with this and similar products, ultimately to eliminating and eventually eradicating malaria. So just really a final word of thanks to our very many stakeholders. I really struggled to fit them all in on this slide, and I'm hopeful I've got as many of them as I can, but this is certainly some of our stakeholders. There will be a few that we haven't got here, I'm sure, but thank you very much to everyone for all your support, and to Nick and the IVCC team for your support too. Thank you.